Okay, so the first thing that we're going to do on these ones, all of them we need to be able to solve with algebra, right, with our logarithms. So we said we've got to follow this whole PEMDAS thing, and when we follow the PEMDAS, we've got to go backwards when we're solving. So I'm going to deal with addition, subtraction stuff first. Again, I'll try and hold anything or store anything in my calculator as I go, if I can. So a plus 18 and a plus 18. 3.2 parentheses 4 raised to the x equals 660. I cannot distribute this 3.2 into here, right? That would be doing multiplication before the exponent, so I have to undo that. So I'm going to divide by 3.2, divide by 3.2, and I'll get 660 over 3.2 on my calculator. 660 divided by 3.2. I got a 206.25. So 4 to the x equals 206.25. It's at this point where my 4, or the base of this exponential expression, is all by itself. At that point, I can log both sides because everybody is safely tucked away. Once I have the log, my x can come down by the log law. So I'll have x log 4 equals the log of 206.25, and that's multiplying the x, so I'm going to divide by log 4. So on my calculator, I'm going to do log 206.25, close parentheses, make sure it's just the log of that, divided by the log of 4, close parentheses, enter. And I get 3.8441. And that's what x should be for my first one. X equals 3.8441. Show me hands, how many people had that? Awesome. What's the one thing I want to do right now before I move on? Because this problem is probably worth about 4 points on the test, right? Store it in x, enter, and just retype the left side of my equation. So 3.2 parentheses 4, close parentheses, raised to the x, minus 18. And poof, 642, 642, check mark. I know that I'm good with that. Is that okay? Based on the fact that 1 and 2 are very similar, I'm going to skip doing 2, but I will let somebody who's 100% sure that they're right. What do you got for it, Kirkwood? 6.824. X equals 6.824. Agreements? Awesome. Okay. So now we'll go down to number 3. And number 3, the only thing that is jumping out to me, it's still exponential because the variable's in the exponent spot. But I got a base of an e. And when I have a base of an e, I'm going to end up using something called a natural log. Everything else is still the same. I still got to get my base by itself. So my first step is add 8, add 8. So then I have 4e to the x equals 20. Divide by 4, divide by 4. E to the x equals 5. And it's at that point right now that I'm going to go ahead and natural log both sides. As soon as I do that, my x can take the log ride down and make it x times the natural log of e. We learned yesterday that the natural log of e is 1. So 1 times x is just x. So x is equal to the natural log of 5. I go on my calculator and do the natural log of 5, close parentheses, 1.609. Please don't write it as 1.6. Give me that extra decimal in there, that extra spot, 1.609 x. And again, we know it's approximate. We rounded it, but that's close enough for what we need for this class. I'm going to store it again in x, just like that. And then I'm going to retype my equation, 4e to the x minus 8, 4e to the x minus 8, and enter, and I get 12. It says it's 12, check mark good. Okay, somebody over here on the other side of the room. What do we got for this one? This side. Somebody. 5.673. 5.678. Is it really? That's just weird. 5.678. That's a very consecutive number there. Agreement on this side? Everybody? Okay. So again, if you're watching this video at home, make sure that you can do that work to be able to get it to that point. Down here, I'm going to go ahead and do number 6 this time. You can go through and try number 5 on your own. Not a huge difference on the stuff. Basically, we're looking at the fact that we've got a much, I guess, nastier, messier looking exponent, but the same process is going to go. This is a base of an e, so I'm going to end up using a natural log, but I got to get that isolated first. So plus 12, 3.2 e to the negative 2x plus 5 equals 984. Divide by 3.2, divide by 3.2, e to the negative 2x plus 5 equals, and again, I would store this value as I'm going through it. 984 divided by 3.2. I got 307.5. I guess that's not too bad of a number. I might not need to store that yet. And then I'm going to natural log both sides. And at this case, when I do that, natural log of e to the negative 2x plus 5 equals the natural log of 307.5. It's where sometimes people have a little bit of trouble with this. This whole thing now gets to come down, but it's grouped. So that means we need this grouping out in front. Negative 2x plus 5 times this equals the natural log of 307.5. We know that the natural log of e will go away. My exponent's been brought down. So on the other side, I have a natural log of 307.5. So I'm going to go ahead and do that. Natural log of 307.5. I get that number. And now I've got a negative 2x plus 5 with nothing else on this side, which means the parentheses become irrelevant. I can just get rid of them. Trying to get the x by itself, so my next step is going to be to move the 5 over, right? PEMDAS backwards, so addition, subtraction has to go first. So I'm going to do minus 5, enter, and then I have to get rid of the negative 2 that's multiplying the x, so I divide by negative 2, divide by negative 2, and I should get negative 0.3642. So x equals negative 0.3642-ish. Again, before I move on, I'm going to store that sucker, so I'll go ahead and store that in x. I go here, and my home screen, I just type in 3.2 e raised to the, now old calculator people, remember you got to put that in parentheses. Newer calculators, you don't have to worry about it. And people who learned that their new calculators actually have this, you don't have to worry about it anymore. So negative 2x plus 5, and then a down arrow minus 12. Crossing my fingers, hoping for a 972. 972 it is. That's a winner. Check mark. So again, if you're watching this at home on these practice problems, go ahead and take these and give it a shot, and hopefully you get x equals. Somebody have that one? Negative what? 308. Can I get somebody else in the room that seconds that? Negative 1.308. Okay. Check mark from people in the room. So again, this is solving using logarithms, either regular logs or natural logs, with singular exponent x's or even more complicated ones. Hopefully that helped. Thanks. See ya.